July 14th, 1944, 3 miles south of Saint-Lô, Normandy. Staff Sergeant Marcus Reynolds watches his 4th Sherman burn this morning. The tank had climbed the hedgerow exactly as doctrine demanded. 12-foot earthen wall, roots older than the United States itself, and for exactly 4 seconds the tank's belly armour faced the concealed German position. 4 seconds, 1 panzerfaust, 5 men who would never see home again. Reynolds knows the mathematics. 38 days since D-Day. 847 Sherman tanks destroyed in bocage country. Allied advance, 1.2 miles. The ancient Norman farmland has become the most expensive real estate in human history, purchased in burning steel and young American lives at a rate that cannot be sustained. Every tank commander in First Army understands the problem. The hedgerows are not hedges. Intelligence photographs taken from reconnaissance aircraft showed simple field boundaries, the kind any farmer would recognize. What those photographs could not reveal was 4 centuries of accumulated reality. Norman farmers had built these barriers beginning in the 1500s, piling earth into walls to mark property lines and contain livestock. Generation after generation added height, planted hawthorn and oak and bramble, let root systems interweave into matrices stronger than concrete. By 1944, each field boundary stood 6 to 12 feet high, 4 feet thick, with root structures extending 8 feet underground. The bocage region contained an estimated 150,000 such obstacles across 60 square miles of countryside. The Germans had spent months studying these ancient walls, calculating firing angles, positioning machine gun nests and panzerfaust teams at precise locations to exploit the single fatal flaw in American armor doctrine. When a Sherman tank attempts to climb a hedgerow, physics becomes the enemy's greatest weapon. The 35-ton vehicle tilts backward at a 45-degree angle. For those critical seconds during the climb, the tank's thickest armour, 3 inches of face-hardened steel on the frontal glacis, points uselessly at the Norman sky. The belly armour, never designed to face direct fire, consists of barely 1 inch of mild steel plate. German gunners positioned 30 yards away have practiced this shot for weeks. 1 panzerfaust rocket, 44 millimeters of shaped charge penetration, striking armor that might as well be paper. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. Reynolds had lost his first tank on June 10th, driver and bow gunner dead before the evacuation hatches even opened. Lost his second tank on June 18th, entire crew this time. The third tank died 3 days ago, and now this 4th burning wreck served as monument to the unchangeable reality that conventional tactics could not solve unconventional terrain problems. First Army casualty reports told a story that senior commanders found increasingly difficult to explain. 40,000 casualties in 38 days of bocage fighting. That nearly equaled D-Day losses, except D-Day had established the beachhead that would win the war. These 40,000 men had died for 1.2 miles of French farmland and no clear path to break through. General Omar Bradley faced an operational crisis that threatened the entire Normandy campaign. Operation Cobra, the massive breakout offensive scheduled for July 25th, required breaking through German defensive lines that had proven impenetrable. Behind those lines waited open tank country, where American armor could exploit its advantages in speed and numbers. But reaching that open country meant solving the hedgerow problem, and 38 days of combat operations had produced no solution. The British attempted to help. Specialized Churchill AVRE tanks equipped with Petard mortars and fascine bundles could clear individual hedgerows with acceptable casualties. The problem was scale. First Army needed to punch through 40,000 prepared defensive positions within 2 weeks. The British had perhaps 50 AVRE tanks available. The mathematics was impossible. American engineers tried everything their training suggested. Pole charges, satchels of TNT on long poles pushed against hedgerow bases and detonated. The explosions sometimes created gaps, but also alerted every German position within half a mile. Tanks approaching the fresh breach rolled directly into pre-registered artillery fire. Casualty rates actually increased. Bulldozer tanks attempted to push through the earthen walls using brute force. The ancient root systems held. Bulldozers bogged down in loose soil, becoming stationary targets for German gunners who had all the time in the world to aim carefully. 3 bulldozer tanks destroyed. In one afternoon, convinced engineers this approach was suicide. Flamethrower tanks tried burning through the vegetation. Norman summers are wet. The hedgerows refused to burn with sufficient intensity to clear obstacles. More importantly, the flames revealed tank positions to German artillery observers, who called down devastating fire missions. The flamethrower experiments ended after 4 days and 17 dead crewmen. Some tank commanders attempted the direct approach, hit the hedgerow at maximum speed and power through. Sherman tanks mounted Ford GAA engines producing 500 horsepower, impressive by any measure. But horsepower meant nothing when 35 tons of steel met 4 centuries of compacted earth and root matrix. The tanks climbed. The tanks exposed their bellies. The tanks died. Every single attempt ended identically. By July 10th, even the optimists understood that breakthrough was impossible without fundamental changes to either equipment or tactics. Staff, officers from Corps headquarters visited frontline units, interviewing tank crews, studying the terrain, searching for insights that might unlock the tactical puzzle. They found only grim consensus. The bocage was impenetrable to conventional armour operations. Lieutenant Colonel James Bates of 2nd Armoured Division wrote in his after-action report, "Tank approaches hedgerow at standard climbing angle. Tank climbs. Tank's underside becomes visible to enemy anti-tank position. Tank dies." This pattern has repeated itself across 60 miles of Norman countryside with mechanical precision. German defensive doctrine has found the perfect counter to American armour mobility. The German perspective revealed sophisticated understanding of the tactical situation. Wehrmacht training manuals from July 1944 captured after the war showed detailed hedgerow defence instructions. Position panzerfaust teams 15 to 30 metres from hedgerow. Sight weapons on standard climbing. Approach angles. Wait for tank belly armour exposure. Fire when underhull is perpendicular to weapon position. 1 shot, 1 kill, 93% historical effectiveness rate. That 93% effectiveness rate was killing First Army. Intelligence estimates suggested German forces had prepared defensive positions at approximately 60% of the bocage hedgerows in the breakout zone. At current casualty rates, breaking through these defences would cost the entire Allied armoured force. Even if such losses were somehow acceptable, and they absolutely were not, the Germans could simply fall back to the next line of hedgerows and repeat the process indefinitely. Strategic implications extended far beyond Normandy. The Allied campaign depended on establishing continental foothold before winter. If armies remained bottled up in the bocage through autumn, Hitler would have time to redeploy divisions from the Eastern Front. The V-weapon program would reach full, operational status. German jet fighters would achieve air superiority over the battlefield. The window for liberating Europe would close, possibly forever. 5,000 Allied soldiers were dying every week in hedgerow country. The Normandy invasion, the largest amphibious operation in human history, involving over 150,000 men on D-Day alone, was grinding to halt 7 miles inland from the landing beaches. The Engineering Corps estimated that developing specialized hedgerow clearing equipment through proper channels would require 6 months of design, testing and production. Combat units could not wait 6 months. They were dying at unsustainable rates while staff officers in rear areas drew blueprints for theoretical solutions to tomorrow's problems. The bocage had become more than a tactical obstacle. It represented everything dysfunctional about military bureaucracy's approach to battlefield innovation. Complex problems supposedly required complex solutions, developed through proper channels by qualified experts with advanced degrees and institutional credentials. The idea that battlefield problems might have simple solutions, discoverable by enlisted men with practical experience, was antithetical to military culture. Officers attended West Point and graduated with engineering degrees. Sergeants followed orders and maintained equipment. The system valued credentials over results. 300 miles away in London, Pentagon liaison officers were already drafting contingency plans for withdrawal from France. The plans remained classified, locked in safes at Allied headquarters, but their existence revealed how seriously senior leadership took the bocage crisis. If Operation Cobra failed, if American armor could not break through German lines, then the entire strategic calculus of the European war would need revision. Meanwhile, scattered across the Norman countryside in maintenance bivouacs and field repair stations, enlisted men were having different conversations. Tank mechanics who kept Shermans running despite combat damage and mechanical failures saw the Hedgerow problem through different eyes. These were men who understood machinery at visceral level, men who had spent years coaxing broken equipment back to life using whatever materials were available. Staff Sergeant Curtis Cullen of 2nd Armoured Division's Reconnaissance Squadron was one such man. At 29 years old, the Tennessee native had joined the Army in 1940 to escape Depression-era poverty. 4 years later, he found himself watching million-dollar machines burn because they could not solve a problem any farmer would recognize: how to get heavy equipment through an obstacle without getting stuck. Cullen understood machinery in ways that tactical manuals never captured. Growing up on Hardscrabble Farm outside Cranfill's Gap, he had learned to keep temperamental tractors running with baling wire and ingenuity. When the plough broke, you did not order replacement parts from factory catalogue and wait weeks for delivery. You welded whatever metal you could find and got back to work before the planting season ended. The Army had trained him in tank mechanics, teaching proper procedures and official protocols. But his real education had come from years of making broken things work, using available resources and common sense. That education was about to change the course of the Normandy campaign in ways that no staff officer or planning committee could have anticipated. On July 12th, Cullen found himself walking through the Omaha Beach area during brief respite from frontline operations. 2nd Armoured Division had pulled back for maintenance and resupply, giving tank crews their first real break since bocage fighting began. Most men headed for makeshift clubs in liberated villages, where warm beer and exhausted French civilians provided temporary escape from the war. Cullen wandered the landing beaches instead, studying remnants of Hitler's Atlantic Wall with mechanic's curiosity. The German beach obstacles fascinated him in ways that tactical briefings never could. Rommel's engineers had created a devil's garden of steel, designed to rip apart Allied landing craft before they could reach the sand. Thousands of obstacles had been emplaced during the spring of 1944, representing enormous investment of German resources and labour. The most common obstacles were called Czech hedgehogs by Allied intelligence, though German designation was Czechan eagle. Each hedgehog consisted of 3 steel angle irons welded together to form 6-pointed star, each point sharpened to penetrate landing craft hulls. Simple, elegant, and manufactured by thousands in Ruhr Valley factories. German engineers had calculated exact dimensions needed to stop Allied vessels without wasting material. Each hedgehog represented roughly 200 pounds of high-carbon steel, harder and more durable than anything American farms typically used for implements. Now these thousands of hedgehogs lay scattered across Omaha Beach like metallic tumbleweeds. Engineer units had bulldozed them into massive scrap piles, while clearing lanes for supply operations. Thousands of tons of premium German steel, originally forged at enormous expense and shipped to Normandy on overloaded trains, now served no purpose beyond cluttering French shoreline. The irony was not lost on Cullen. Germany's best metallurgy had become America's disposal problem. Walking among twisted steel, Cullen examined hedgehog construction with professional eye. The angle irons were substantial, probably 4 inches by 4 inches, welded at precise angles to create maximum structural strength. Even after weeks of salt spray and explosive concussion from naval bombardment, the joints remained solid. German military standards demanded welds that could withstand battle damage and environmental stress. This was not scrap metal in any meaningful sense. This was premium raw material that happened to be shaped wrong for current applications. Kulin knelt beside particularly intact hedgehog, tracing sharp steel points with his finger. The Germans had designed these obstacles to penetrate and tear, to rip through relatively thin aluminum hulls of Allied landing craft using sharp steel applied with sufficient force. What rips through steel might cut through roots. Norman hedgerows were essentially organic obstacles, centuries of accumulated root growth, binding soil and stone into seemingly impenetrable barriers. But roots, however ancient and thick, were still organic material. They could be cut, torn, or broken if sufficient force was applied in the right direction. The problem was applying that force without exposing tank vulnerabilities. Current doctrine required tanks to climb hedgerows, presenting thin belly armor to German gunners positioned for exactly such opportunities. But what if tanks did not climb the obstacles at all? What if they went through them instead, keeping thick frontal armor facing the enemy, while using raw mechanical force to tear through root structure? Kulin pulled out C-ration box and began sketching with pencil stub. The concept was almost embarrassingly simple. Take German steel, reshape it into forward-facing tusks, and weld them to Sherman's frontal slope. Tank would approach each hedgerow straight on, using its 35-ton weight and 3-inch frontal armor to punch through obstacle while remaining protected from enemy fire. Let the German steel do the work it was designed for, just in different direction. The sketch showed 4 steel prongs, each approximately 4 feet long, angled slightly downward to bite into base of each hedgerow. The prongs would need to be positioned to clear tank's main gun and not interfere with driver's vision blocks. Most importantly, they would need to be strong enough to withstand tremendous stresses of punching through centuries-old root systems without breaking off or damaging tank's hull structure. Engineering calculations filled margins of improvised blueprint. Sherman tank weighed 35 tons and could generate approximately 1,500 foot-pounds of torque at drive sprockets. Applied through properly designed steel tusks, that force should be more than sufficient to tear through organic obstacles that had stopped previous attacks only because tanks had approached them from tactically disadvantageous angles. The solution was not more power or better armor. It was simply applying existing power in smarter direction. Beauty of the concept lay in its simplicity and economy. No complex manufacturing processes needed. The steel was literally lying around in piles, free for taking. Welding work could be accomplished by any qualified tank mechanic using standard field equipment. Total material cost per tank, $0. Time. Perhaps 3 to 4 hours per modification. Official approval. Unnecessary, since modifications could be classified as field expedient repairs rather than engineering changes requiring formal review. But simplicity was also concept's potential weakness. Military culture inherently distrusted simple solutions to complex problems. If hedgerow breakthrough was really as easy as welding scrap steel to tank fronts, why had MIT-trained engineers not already thought of it? Why were staff officers spending weeks developing elaborate tactical schemes when solution might be hiding in plain sight among German beach obstacles? Kulin understood institutional dynamics at work. He was sergeant in army that valued formal education and proper procedures above practical experience. His background was farming and mechanical repair, not structural engineering or metallurgy. Suggesting that complex tactical problems might have simple solutions would be interpreted as presumptuous at best, insubordinate at worst. The army had procedures for equipment modifications, and those procedures did not start with enlisted men sketching ideas on ration boxes. Proposals moved up chain of command through proper channels. Technical review boards examined stress calculations and material specifications. Field testing occurred at proving grounds under controlled conditions. Implementation required months of bureaucratic processing and formal authorization at multiple levels. Still, concept refused to leave his mind. Every calculation he ran suggested idea should work. German steel was strong enough for application. Sherman tanks had sufficient power to drive modified system through typical hedgerow obstacles. Most importantly, approach would keep American armor in tactically advantageous positions while accomplishing breakthrough mission that had cost 847 tanks using conventional methods. Walking back toward 2nd Armored's bivouac area, Kulin made his decision. He would build prototype, test it himself, and present results rather than theories. If concept worked, demonstration would be more persuasive than explanation. If it failed, at least he would have tried something different instead of watching more tank crews die attempting impossible climbs over ancient Norman walls. The German steel would get second chance to serve its original purpose, cutting through whatever stood in its way. Next morning, Cullen approached Staff Sergeant Joe Angelo of Ordnance Section with his sketched modifications and proposition. Angelo had worked as welder in Detroit's tank arsenal before war and understood both Sherman construction and realities of field repairs. More importantly, he shared Kulin's frustration with watching American armor die for inches of French farmland. Angelo studied C-ration box blueprint with professional interest. Concept was mechanically sound, he concluded, though execution would require careful attention to weld, placement and stress distribution. Sherman's frontal hull was designed to mount additional equipment, but concentrated loads needed proper reinforcement to prevent structural failure. Still, modifications were well within standard field maintenance capabilities. Working together, they selected steel from largest hedgehog pile near Omaha Beach. Each Czech hedgehog yielded enough material for one complete tank modification with steel left over for reinforcement brackets. Angelo's cutting torch-shaped angle iron into 4 tusks, each 4 feet long and angled 15 degrees downward to bite into hedgerow base structures. Points were sharpened to concentrate force, while rear portions were flattened for maximum weld surface area. Welding work took place behind 2nd Armored's maintenance tents, away from curious officers who might ask uncomfortable questions about unauthorized modifications. Angelo's Detroit experience showed in every bead as he attached reinforcement plates to distribute stress loads across Sherman's hull structure. Each tusk received double welds at critical stress points, creating joints stronger than original German construction. By noon on July 13th, prototype was complete. Sherman tank number 20,857 now carried 4 steel tusks, protruding from its frontal slope like mechanical fangs. Modification added approximately 800 pounds to tank's front end, but remained well within acceptable weight distribution parameters. Most importantly, tusks cleared all vision blocks and weapon systems, while providing maximum obstacle-penetrating capability. Test site was typical Norman hedgerow 3 miles behind front lines, selected for both tactical realism and relative safety from German observation. Obstacle measured 15 feet in height, with root systems extending approximately 8 feet underground, representing average bocage conditions. Intelligence reports indicated similar barriers existed throughout breakout zone, making this test directly applicable to operational requirements. Kulin climbed into driver's position, while Angelo served as tank commander for demonstration. Sherman's Ford GAA engine rumbled to life, 500 horsepower, ready to drive 35 tons of American steel through whatever obstacle stood ahead. Standard doctrine would require this tank to approach Hedgerow at climbing angle, exposing vulnerable belly armor to hypothetical enemy gunners. Kulin's approach would be fundamentally different. At exactly 1400 hours on July 14th, 1944, Sherman tank 20,857 approached Test Hedgerow at 8 miles per hour, tusks aimed directly at obstacle's base. Steel points bit into centuries-old root structure with surprising ease, ancient organic matter no match for German metallurgy, applied with American mechanical force. Root fibers snapped with sounds like breaking piano wire as 35. Tons of armor pressed forward. Breakthrough moment lasted exactly 47 seconds. Dirt cascaded over Sherman's hull as tank's momentum carried it through Hedgerow's weakest structural point. Instead of climbing over obstacle and exposing vulnerabilities, tank had punched hole through barrier while maintaining tactical protection. Ancient Norman stonework crumbled as modern American engineering completed what German steel had started. Sherman 20,857 emerged on Hedgerow's far side with frontal armor intact and weapon systems ready for immediate engagement. Tusks showed minimal damage despite tremendous stress loads, confirming Angelo's structural calculations. Most importantly, entire breakthrough had been accomplished without exposing tank's vulnerable underside to enemy fire positions. Angelo's radio crackled with reports from observation post. Captain Morris had witnessed demonstration and requested immediate repetition for verification. Second, test run duplicated first results with mechanical precision, 49 seconds this time, accounting for slight variations in hedgerow density and approach angle. Principle was confirmed. Properly applied German steel could cut through Norman root systems faster and safer than any climbing technique. Word of successful test reached Colonel Maurice Rose within 2 hours. Rose, commanding officer of 2nd Armoured Division, had lost more tanks to Hedgerows than to German panzers and was desperately seeking tactical innovations. He arrived at test site with small staff group, including Major General Leonard Guerreau from 1st Infantry Division, who happened to be visiting Rose's headquarters when news of demonstration arrived. Third test run was performed for general officer evaluation. Culin drove, while Angelo provided technical commentary over RadioNet. Sherman 20,857 approached fresh hedgerow section, tusks positioned for optimal root cutting angles. This demonstration lasted 43 seconds and produced identical results: complete obstacle penetration, with zero armor vulnerability and immediate tactical readiness upon breakthrough. General Guerreau's reaction, recorded in his aide's field notes, was immediate and emphatic. Why the hell didn't we think of this? Solution seemed so obvious in retrospect that senior officers questioned their own tactical judgment. Complex problems supposedly required complex solutions, but Culin's innovation succeeded through aggressive simplicity rather than engineering sophistication. Rose immediately ordered technical evaluation by division engineers. Major Harold Cohen examined tusk attachment points and pronounced modifications structurally sound for combat operations. Welds met military specifications, stress distribution was properly calculated, and added weight remained within acceptable parameters for Sherman operational requirements. From engineering perspective, concept was ready for immediate field implementation. Tactical implications were staggering. If every Sherman in First Army could punch through hedgerows instead of climbing over them, entire bocage campaign could be revolutionized. Tank casualties would plummet, while breakthrough speeds increased dramatically. Operation Cobra's success might depend on exactly this kind of tactical innovation applied at exactly right moment in exactly right place. But scaling concept from one prototype to 1,400 operational tanks presented enormous logistical challenges. Every Sherman in breakout force would need modification within 11 days before Cobra's scheduled launch. Operation would require every available welder, every scrap pile of German steel, and round-the-clock work schedules that pushed maintenance capabilities to absolute limits. General Bradley received notification of Culin's demonstration that evening, while reviewing final Cobra plans at First Army headquarters. His response was characteristically direct: implement immediately across First Army, regardless of resource requirements or procedural complications. Bocage problem had found its solution in Tennessee Sergeant's practical innovation and German beach obstacle steel. Race against Operation Cobra's launch date had begun. General Bradley's order reached every armoured unit in First Army by 1800 hours on July 14th. Directive was unprecedented in scope and urgency. Modify 1,400 Sherman tanks with hedgerow cutting devices within 11 days, using available German steel and field welding capabilities. Largest field modification program in military history would be accomplished without factory support, specialized equipment, or extended testing procedures. Colonel John Wellborn of 1st Army Ordnance Section faced impossible mathematics problem. 1,400 tanks requiring 4 to 6 hours of modification work each meant approximately 7,000 man-hours of welding labor. His available workforce consisted of 127 qualified welders distributed across 6 armored divisions. Working around clock in 8-hour shifts, maximum theoretical output was 3,048 welding hours per day. Numbers suggested success was mathematically impossible within 11-day deadline. Staff Sergeant Angelo became unlikely coordinator of largest military innovation program since Manhattan Project. His Detroit welding experience made him Army's leading expert on technique he had invented 3 days earlier. Angelo's crash course in mass production began with analyzing exactly how much German steel each division could access and how quickly cutting torches could reshape hedgehog angle iron into usable tusks. Steel inventory was surprisingly encouraging. German engineers had positioned approximately 12,000 Czech hedgehogs along Omaha and Utah beaches. Each hedgehog contained enough material for one complete tank modification with surplus steel remaining for reinforcement brackets. Limiting factor was not raw material, but processing capacity. Cutting torches operated by tank mechanics could reshape perhaps 50 hedgehogs per day, creating bottleneck that threatened entire program. Major General Clarence Hubner of 1st Infantry Division solved processing problem with characteristic aggression. Every acetylene torch in Normandy, including equipment borrowed from Navy beach construction units and British Royal Engineers, was requisitioned for steel cutting operations. French civilians with metalworking experience were hired as contract laborers, paid in American cigarettes and chocolate rations. Beach areas transformed into massive metalworking operations, running 24 hours per day under improvised canvas shelters. Tank crews themselves became part of production process. Drivers and assistant drivers, normally responsible only for vehicle maintenance, received accelerated training in basic welding techniques. Modifications were simple enough that experienced welders could handle critical structural joints, while tank crews performed preparatory work and finishing operations. This approach doubled effective workforce size, while giving crews intimate familiarity with their modified equipment. Quality control presented enormous challenges. Angelo's prototype had succeeded because Detroit-trained welders performed every joint to automotive industry standards. Mass production threatened to compromise structural integrity through inexperienced welding, improper stress distribution, or inadequate reinforcement. Tank crews would die if modifications failed under combat stress, making quality assurance literally matter of life and death. Solution emerged from 1st Armored Division's maintenance procedures. Master Sergeant Ralph Morrison established 3-tier quality control system. Experienced welders handled all primary structural joints. Tank crews performed secondary work under direct supervision. Qualified inspectors checked every modification before operational approval. This system maintained structural standards while maximizing production throughput. By July 18th, program had achieved unexpected momentum. Competition developed between divisions over modification completion rates, with 2nd Armored Division claiming lead at 67 completed tanks. 3rd Armored Division responded by implementing continuous production schedules that kept welding operations running even during air raid warnings. Rivalry increased overall production while maintaining quality standards through professional pride. Weather became critical factor on July 20th, when heavy rain made outdoor welding nearly impossible. Maintenance crews improvised canvas shelters and windbreaks to protect welding operations from Norman summer storms. Delay cost precious hours, but also provided time for steel preparation work that had fallen behind aggressive schedule. By time weather cleared, processing had caught up with welding capacity. Assassination attempt on Hitler that same day created strategic uncertainty throughout Allied command structure. If German leadership collapsed, Operation Cobra might be unnecessary. If Hitler survived, breakout would proceed as planned. Either way, tank modifications continued on schedule. Bradley's staff calculated that incomplete modifications posed greater risks than potentially unnecessary ones. Tank crews adapted to their modified equipment through accelerated training programs. New tactics required different approaches to obstacle negotiation, with emphasis on straight-line attacks rather than climbing maneuvers. Drivers practiced coordinating speed and angle for maximum breakthrough effectiveness, while maintaining tactical formation. Learning curve was steep but manageable for experienced crews. Supply logistics complicated entire operation. 890 tons of German steel required transportation from beach collection points to division maintenance areas. Welding rod consumption exceeded monthly allocation within 4 days, requiring emergency resupply from British sources. Acetylene bottles emptied faster than replacement supplies could arrive from England. Every aspect of program strained logistical systems designed for routine maintenance rather than mass innovation. French civilian reaction to steel cutting operations ranged from curiosity to active assistance. Local blacksmiths offered traditional metalwork advice that sometimes improved upon American techniques. Farmers provided information about hedgerow construction that helped optimize tusk design for specific soil conditions. Collaboration between American technology and French agricultural knowledge created unexpected synergies that accelerated production. By July 23, 847 tanks carried Culin's hedgerow cutting modifications. 60% completion rate represented remarkable achievement under impossible circumstances, though Bradley's staff calculated that additional coverage would significantly improve Cobra's breakthrough potential. Weather delays on July 24 provided crucial extra time for final modifications, bringing total equipped tanks to 912. Human cost of accelerated program was measured in exhausted welders working 18-hour shifts and maintenance crews functioning on minimal sleep. Hospital tents treated burns, cuts, and exhaustion injuries at rates normally associated with combat operations. Intensity was unsustainable for extended periods, but manageable for 11 days required to meet Cobra's launch date. Final inspections on July 24 revealed modification quality that exceeded expectations. Angelo's production standards had been maintained despite enormous time pressure and resource constraints. Tank crews reported confidence in their equipment and eagerness to test innovations against real hedgerow obstacles, defended by actual German positions. Mood throughout First Army combined exhaustion with anticipation as Operation Cobra approached. At 0600 hours on July 25, 912 Sherman tanks carrying hedgerow cutting devices moved into position for largest breakout operation in European theatre history. Tennessee Sergeant's innovation, implemented through German steel and American industrial improvisation, was about to transform tactical balance in Normandy in ways that German defensive planners could never have anticipated. Operation Cobra commenced at 1100 hours on July 25, with largest close air support mission in military history. 1,800 heavy bombers of 8th Air Force dropped 4,700 tons of explosives on German positions in rectangular target zone, measuring 7,000 yards by 2,500 yards. Bombardment lasted 90 minutes and pulverized every visible German defensive position within impact area. 550 fighter bombers followed heavy bombers, strafing German trenches and strongpoints that had survived initial bombardment. 47 Thunderbolts and P-51 Mustangs made repeated passes at treetop level, expending thousands of rounds of 50 caliber ammunition and 500-pound bombs on targets of opportunity. Air preparation was designed to stun German defenders and destroy their communications before American armor began breakthrough assault. At 1300 hours, 912 modified Sherman tanks rolled forward in largest armored assault since Kursk. Lead elements belonged to 2nd Armored Division. with Kulin's original prototype tank, 20,857, leading 1st Battalion's advance. Behind Shermans came infantry from 1st and 4th Infantry Divisions, ready to exploit whatever breakthrough armour could achieve. First Hedgerow engagement occurred at 13:23 hours when Company A, 1st Battalion, encountered typical Norman barrier that had stopped previous attacks for 3 days. German machine gun positions were pre-sighted to cover climbing approaches that every previous assault had attempted. Panzerfaust teams occupied concealed positions calculated to engage tanks at maximum belly armour vulnerability. Instead of climbing, lead Sherman approached Hedgerow straight on at 8 miles per hour. Steel tusks bit into ancient root structure with mechanical precision, while thick frontal armour deflected small arms fire from German positions. Breakthrough lasted 41 seconds, almost exactly matching test results from 2 weeks earlier. German gunners positioned for flanking shots at climbing tanks found themselves facing 3 inches of frontal armour instead of 1 inch of vulnerable belly plating. Psychological impact on German defenders was immediate and devastating. Hedgerow positions that had seemed impregnable suddenly became death traps as American armour appeared from impossible directions. Machine gun crews abandoned positions designed around climbing tank tactics. Panzerfaust teams discovered their weapons were useless against frontal armour approaches that previous doctrine had made impossible. By 1400 hours, 2nd Armoured Division had advanced 4 miles through bocage country that had resisted breakthrough attempts for 34 days. Modified Shermans punched through hedgerow after hedgerow with mechanical reliability, maintaining tactical momentum that conventional tactics could never sustain. Each barrier that had previously required hours of preparation and massive casualties now fell to direct assault in less than 1 minute. 3rd Armoured Division matched 2nd Armoured's breakthrough pace on eastern flank, advancing 3.7 miles by 1500 hours. Their modified tanks encountered heavier German resistance, but overcame defensive positions through sheer tactical surprise. Months perfecting anti-tank tactics against climbing approaches. They had no doctrine for countering direct frontal assault through obstacles that tanks were supposedly incapable of penetrating. Cascade effect began on Day 2 of Operation Cobra. German defensive lines, carefully positioned to exploit hedgerow climbing vulnerabilities, suddenly found themselves tactically obsolete. Defensive positions that had required weeks to construct became useless overnight. More importantly, German reserves positioned to counter expected American breakthrough patterns were caught completely out of position by speed and direction of actual advance. 1st Infantry Division exploited armour breakthrough with unprecedented infantry-tank coordination. Instead of waiting for tanks to climb hedgerows and expose themselves to anti-tank fire, infantry could follow immediately behind armour that punched through obstacles while maintaining tactical protection. Synergy between modified equipment and traditional infantry tactics multiplied effectiveness of both arms. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By July 27th, American forces had advanced 7 miles from their starting positions, capturing strategic town of Saint-Lô and threatening German communications throughout Bocage region. Advance rate exceeded staff planning estimates by 300%, while tank casualties remained 60% below pre-Cobra levels. Modified equipment was performing better than optimistic projections had suggested possible. German resistance began fragmenting as tactical doctrine proved inadequate for new battlefield reality. Battalion commanders reported American tanks appearing in sectors that were supposed to be impassable to armour. Regiment headquarters received contradictory reports about American breakthrough directions that seemed tactically impossible. Carefully, coordinated defensive system began breaking down as individual unit commanders made desperate local adjustments to counter threats they did not understand. Wehrmacht after-action reports captured after war revealed depth of German confusion. One report from Panzer Division dated July 26 stated, American tanks demonstrate new capability to penetrate bocage obstacles without exposing vulnerable hull sections. Previous defensive calculations rendered invalid. Request immediate tactical guidance from Army Group Headquarters. Army Group B never provided that guidance because they had no answer. German defensive doctrine in Normandy had been built entirely around exploiting Sherman tanks' climbing vulnerability. When that vulnerability ceased to exist, entire defensive architecture collapsed. No backup plan existed because German planners had never imagined Americans could solve Hedgerow problem so completely and so quickly. On July 28th, Third Army elements broke through German main defense line entirely, advancing 12 miles in single day and capturing vital road junction at Coutances. Breakthrough created gap in German lines that tactical doctrine said was impossible to achieve without weeks of preparatory operations. Rommel's carefully planned defensive system had been rendered obsolete by Tennessee sergeants' innovation and American industrial improvisation. Tank casualty statistics told story of tactical revolution. During pre-Cobra period from June 6th to July 24th, First Army had lost 847 tanks in 48 days for 1.2 miles of advance. During first 4 days of Cobra, from July 25th to July 28th, modified tank forces lost 94 vehicles while advancing 25 miles and breaking through German main defensive positions. Casualty reversal was so dramatic that intelligence officers initially suspected reporting errors. Multiple verification requests went to frontline units asking for confirmation of casualty figures. Every response confirmed same pattern. Modified tanks were surviving at rates that seemed impossible compared to pre-modification experience. German High Command's response revealed depth of tactical confusion. Emergency conferences in Berlin discussed mysterious American tank modifications that seemed to violate basic mechanical principles. Wehrmacht Technical Intelligence requested immediate examination of captured American equipment to understand how Shermans had suddenly acquired obstacle-penetrating capabilities that German engineers considered theoretically impossible. German intelligence report from August 1st, captured after war, stated, Allied forces employ unknown tank modification consisting of steel projections welded to frontal hull. Modification enables direct penetration of bocage obstacles previously considered impassable. Origin of technology unknown. Recommend immediate counter-development of defensive measures. That counter-development never occurred because Germans lacked time and resources. By time Wehrmacht understood what Americans had done, breakthrough was complete, and German forces were in full retreat towards Seine River. Single tactical innovation had cascaded into operational victory that changed entire strategic situation in Western Europe. By July 30th, Operation Cobra had achieved complete tactical success. American forces controlled 60 miles of previously German-held territory, while German army groups retreated towards Seine River in growing disorganization. Bocage breakthrough had been accomplished in 6 days rather than 6 weeks that staff planners had considered optimistic. General George Patton's Third Army poured through gap created by modified tank assault, beginning sweeping maneuver across French interior that would carry American forces to German border within weeks. Liberation of Paris became possible. Liberation of France became inevitable. Strategic deadlock that had threatened entire Allied campaign had been broken by welded German steel and American ingenuity. Cullen received field promotion to technical sergeant on July 31st, along with orders to report to First Army headquarters for consultation on extending modification program to additional tank units. His innovation was being adopted across Allied armoured forces, with British and Canadian units requesting immediate technical assistance in implementing similar modifications to their Churchill and Sherman tanks. British tank crews, who received modified equipment in early August, reported similar results. Lieutenant Colonel David Wilson of 7th Armoured Division wrote in August 5th after-action report, American Hedgerow cutting device performs exactly as advertised. Our tanks can now penetrate bocage obstacles that previously required specialized AVRE vehicles. Recommend immediate implementation across all armored formations. Strategic impact of Culin's armors. Innovation extended far beyond Normandy breakout. Modified tanks proved effective in other European terrain featuring similar obstacles. Hedgerows in Belgium and Netherlands fell to same technique that had broken German defences in France. Stone walls in German border regions yielded to tusks originally designed for Norman route systems. More importantly, innovation demonstrated that tactical problems could be solved through field improvisation rather than centralized planning. Army began encouraging similar bottom-up innovation, creating formal channels for enlisted personnel to submit equipment modification proposals. Culin's success proved that practical experience sometimes mattered more than formal credentials. Pentagon analysis, conducted in September 1944, estimated that hedgerow cutting modifications saved approximately 10,000 American lives during Cobra breakout alone. Additional lives were saved in subsequent operations, where modified tanks maintained tactical advantage. Total strategic value was incalculable, measured in shortened war duration and reduced Allied casualties across entire European theatre. Culin himself never sought recognition for his achievement. When reporters attempted to interview him in August 1944, he declined, stating he was simply doing his job like every other soldier. When Army public relations officers proposed featuring him in training films, he refused, saying credit belonged to all maintenance personnel who had implemented mass production program. His humility was genuine, but also reflected understanding of military culture. Enlisted men who drew attention to themselves often faced resentment from both superiors and peers. Better to remain anonymous, do good work, and let results speak for themselves. That philosophy served Culin well throughout his military career. War Department awarded Culin Legion of Merit on August 15, 1944. Citation read, "For exceptionally meritorious conduct in performance of outstanding services." Sergeant Culin's ingenuity and initiative in developing device to facilitate tank operations in hedgerow terrain contributed materially to success of combat operations in European theatre. General Dwight Eisenhower mentioned hedgerow cutter in letter to General George Marshall dated August 23rd. The device represents exactly the kind of practical problem-solving we need to encourage throughout our forces. One sergeant with welding torch accomplished what months of staff planning could not achieve. We should learn from this example. But military bureaucracy learned slowly. Despite Culin's success, equipment modification procedures remained cumbersome and centralized. Formal innovation programs created after war still required extensive review processes that discouraged rapid field improvisation. Culture of credentialism persisted, valuing advanced degrees over practical experience in most circumstances. Culin's contribution did inspire changes to Army technical training. Maintenance courses began emphasizing creative problem-solving alongside standard procedures. Instructors used hedgerow cutter as case study in applied engineering, teaching soldiers that solutions sometimes existed outside official manuals. Small shifts in military culture that might prevent future bocage-type deadlocks. Quiet triumph came months later, when Culin returned to Tennessee after Germany's surrender in May 1945. He resumed civilian life, applying same practical problem-solving approach that had revolutionized armored warfare in Normandy to everyday challenges. Same hands that had sketched tank modifications on sea ration box were back to fixing farming equipment and maintaining machinery. He married in 1946, started family, worked various jobs in automotive and industrial sectors where welding skills remained valuable. He never talked much about war, like most veterans of his generation. When asked about hedgerow cutter at veteran gatherings, he typically changed subject or credited others for implementation success. Operation Cobra's success had proven that most decisive innovations often came from ground up rather than top down. Sometimes, best solutions to complex problems were surprisingly simple, waiting to be discovered by someone with enough practical experience to see past conventional wisdom. Sometimes formal credentials mattered less than ability to recognize patterns and apply existing resources in novel ways. German steel that had been designed to stop Allied invasion ended up enabling Allied breakthrough. Weapons intended for one purpose found new application in completely different context. Resources dismissed as scrap became critical components in tactical revolution. Material reality mattered less than creative application of available materials. Historical irony extended beyond immediate tactical situation. German engineering excellence, represented by precisely manufactured Czech hedgehogs, contributed directly to German defeat in Normandy. Resources invested in Atlantic Wall construction came back to haunt Wehrmacht in form of welded tank modifications. Every ton of steel shipped to French coast in 1943 and 1944 eventually served Allied cause. Bocage itself represented another irony. Norman farmers who built hedgerows over 4 centuries to organize their agricultural land never imagined those barriers would become decisive military obstacles in 20th century mechanized warfare. Ancient farming practices accidentally created perfect defensive terrain that temporarily stopped most powerful military force ever assembled. And single American sergeant solved problem those farmers had inadvertently created, using steel from German defensive obstacles to overcome French agricultural obstacles, demonstrating that creative intelligence could defeat both natural and man-made barriers when applied with sufficient ingenuity and determination. Tank warfare experts studying Normandy campaign in decades after war consistently identified Cullen's innovation as one of 3 most important tactical developments of bocage fighting. Other 2 were improved infantry tank coordination and effective use of artillery support. But hedgerow cutter was only development that fundamentally changed battlefield physics, making possible what had previously been impossible. Military historians debate whether Operation Cobra would have succeeded without modified tanks. Some argue breakthrough was inevitable, given Allied superiority in numbers and air power. Others contend hedgerow obstacle would have prevented breakthrough regardless of resource advantages. Most historians conclude truth lies somewhere between extremes. What remains undebatable is that modified tanks reduced Allied casualties dramatically while accelerating breakthrough pace significantly. Whether modifications were absolutely necessary or merely helpful, they unquestionably saved thousands of American lives and shortened Normandy campaign by weeks. In war, saving lives and saving time both matter tremendously. Technology lesson from hedgerow cutter remains relevant decades later. Advanced weapons and sophisticated equipment provide advantages, but adaptability and creative problem-solving often matter more than raw technological superiority. Ability to modify existing resources for unexpected applications frequently determines battlefield success more reliably than possession of newest equipment. Cultural lesson remains equally relevant. Organizations that empower frontline personnel to identify problems and propose solutions to perform better than organizations that concentrate decision-making authority in distant headquarters. Trust in distributed expertise produces faster innovation cycles than centralized planning processes, regardless of planners' credentials or expertise. Personnel lesson persists across generations. Individuals with practical hands-on experience solving real-world problems often see solutions that theoretically trained experts overlook, not because practical experience is superior to formal education, but because both perspectives contribute valuable insights. Best organizations leverage both types of expertise rather than privileging one over other. Cullen lived quietly for 2 more decades after war, working in industrial maintenance and raising family in Tennessee. He died in 1963, at age 48 from heart attack. Local newspaper ran brief obituary mentioning his military service, but not specifically describing hedgerow cutter innovation. Most neighbors never knew quiet maintenance worker had changed course of World War II. In 1987, Tennessee Historical Society erected monument in Cranfill's Gap, commemorating Culin's contribution to Allied victory. Monument featured replica hedgerow cutting device mounted on stone base, with bronze plaque describing innovation's impact on Normandy campaign. Small ceremony attended by surviving 2nd Armored Division veterans honored man who had saved their lives 33 years earlier. National Museum of United States Army in Fort Belvoir, Virginia, includes hedgerow cutter in permanent collection, displayed alongside other significant innovations from World War II. Museum placard tells Culin's story, emphasizing that decisive innovations often come from unexpected sources. Thousands of visitors each year learn about Tennessee sergeant who solved problem that had stumped West Point engineers. Military academies now teach Cullen case study in leadership courses, using hedgerow cutter story to illustrate importance of listening to enlisted personnel and encouraging bottom-up innovation. Lessons learned from Normandy breakthrough inform current doctrine on field expedient modifications and tactical adaptation. But perhaps most important legacy is simpler and more personal. Veterans who fought through bocage in modified tanks lived long enough to raise children, build careers, and contribute to post-war society. Men who would have died in burning Shermans attempting impossible hedgerow climbs instead survived to become fathers, teachers, business owners, community leaders. Their grandchildren and great-grandchildren exist because one sergeant refused to accept that complex problems required complex solutions, because one mechanic understood that right tool applied in right direction could overcome centuries-old obstacles, because one soldier valued practical results over procedural compliance. Curtis Culin's welded German steel did not win World War II, but it saved thousands of men who did win that war, and in saving them, it changed everything. Sometimes greatest heroism comes not from exceptional courage under fire, but from exceptional intelligence applied to impossible problems. Sometimes changing history requires nothing more than welding, torch, scrap metal, and refusal to accept that solutions do not exist. Norman hedgerows still stand today, marking field boundaries much as they did in 1944. French farmers still use same ancient walls their ancestors built 5 centuries ago. But those hedgerows no longer represent impassable barriers. They represent proof that human ingenuity can overcome any obstacle when necessity demands innovation and creativity meets determination. German steel that crossed Atlantic as invasion defense returned across that same ocean as liberation enabler. Tennessee farmer's son who learned welding on broken farm equipment applied those skills to broken military doctrine. American tanks that had been dying by hundreds broke through German defenses by thousands, and war that might have lasted years longer ended months sooner, all because one sergeant looked at pile of scrap metal and saw possibility instead of garbage, all because practical wisdom mattered as much as formal education, all because someone with right experience asked right question at right moment and refused to accept wrong answer. That remains Curtis Culin's true legacy, not bronze plaques or museum displays or military citations, important as those may be. His legacy lives in principle that problems have solutions, obstacles can be overcome, and sometimes simplest answer is correct answer, waiting to be discovered by person willing to look past conventional wisdom toward practical reality. The bocage breakthrough proved that one person with welder and idea could change course of history. That lesson transcends World War II, transcends military operations, transcends specific historical moment. It remains relevant wherever complex problems demand creative solutions and established procedures prove inadequate to novel challenges. In summer of 1944, Curtis Culin reminded world that credentials matter less than capability, rank matters less than results, and sometimes most important innovations come from people nobody expected to contribute anything beyond following orders and maintaining equipment. He was right then. That truth remains right now, and hedgerows of Normandy stand as eternal monuments to power of practical ingenuity applied with courage and determination to problems others considered unsolvable. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.